I would say so for civil, it becomes important when things go wrong, I would say, on a site. All of a sudden, civil engineering becomes very important. When you push send on those submittals and you watch that email go. That's special, just to be able to be, okay, for this 1 second, we're done.
Yeah.
First of all, and proud of the work that we sent out. New grads, what you're getting in a classroom is awesome, and that's a good base. But I also think for solar especially, being able to have that attitude of flexibility goes a long way with the fast pace that we're working in.
Welcome back to another episode of Sounds of Solar. I'm your host, Russell Hamilton, and I'm accompanied by
Prahlad Shivshankran here.
As you can see, Chris is absent from today's podcast. He is down in the Southwest doing some mountain biking.
Yeah, he definitely doesn't miss us.
No, he's not missing us right now. So Prati, we missed you the last couple episodes.
Yeah,
Where were you at? What was going on?
I really wanted to be there for those two. I was trying my best to get all my work done, but I think I had my birthday on February 1st was my birthday, and I think once you get older, you get more projects.
Well, happy birthday.
Thank you. So yeah, but missed it, but I love the episode.
So today's episode, we're going to be focusing on the civil side of utility scale solar projects and the ins and outs of what the civil does regarding solar. And today we have on Eliza, who is one of our civil project managers. Welcome, Eliza.
Yeah, thanks for having me. I'm excited to be here.
Yeah, we're excited for you to be here. So we've had structural on, which was Chris. We've had hydrology, Byron. Now let's talk about civil. But before we get there, let's talk about your background. How did you get to this point? What got you into civil? Tell us your journey. Tell us how you got here.
So I grew up on the East Coast, and I am a fourth generation engineer. So my dad's a mechanical engineer. And so our house, we had an A-frame house. My dad actually, in the 70s, hippie parents, they installed solar on the side of the roof. And so my dad did that. He also has he's got a patent from 50 years ago on commercial rooftop solar. So I guess, full circle, here I am with civil solar and kind of going back to my roots with that. I've got 4 children. My youngest is 12 and oldest is 18. And you can relate to having teenagers, right, Russ?
Yes, I got 3 of them.
Yep. So yeah, that makes for busy home life. But yeah, about 5.5 years ago, decided to come back to engineering and was lucky enough to end up at EVS and working in renewables and solar.
Okay, well, let's talk about just a little bit about civil and kind of your project management responsibilities. We're electrical, right? So we work with you. I've been on projects with you specifically, but I don't exactly know all the ins and outs of the job that you do, and tell us some of the challenges and things that you do as a project manager and how civil affects the entire process of the solar project.
As you guys know, the star of our projects is electrical, but when
we always think it's civil side.
Yeah, I know. I always think it's civil because they're first, right? Yeah. So
we go first in the meetings. So that's how that
always works. Sit there for 45 minutes, daydreaming. 15 minutes electrical, slam it all in. Okay.
Well, that's funny. Yeah, I would say so for civil. I feel like that it becomes important when things go wrong, I would say, on a site. If something's not going right, all of a sudden civil engineering becomes very important, whether that's, something happening with erosion or some kind of a design, weather impacts, whatever it may be. But civil engineering becomes very important. I feel like we're kind of in the background for the most part. But as far as a project manager, it's a role that I like a lot. I get to work with an awesome team. That's, probably my favorite part is just getting to work with all of the fun people at EVS that I can work with. And
how many people do you lead?
We've got 7, so I get to work with them on projects. And right now we're doing projects in California, Arizona, Texas, Nebraska, Louisiana, Florida, Maryland. So we're really working all over the place, and each area has different, requirements and different topography or soil conditions. And so that leads to a lot of variety in what we do. And one of the challenges maybe, but also one of my favorite parts is some of that variety. It's not a cookie cutter, here's your site, let's do the civil design, and it looks the same every time. Really, every project is is pretty unique in that sense. So,
And what is civil design? Like, how does it start? Like, I think that's something, since we both are electrical and Chris is structural, we sometimes tend to forget, like, where does civil come in? And when, like, let's say we have different stages of a project, right? So we go 10, 30, 60. So in our head, we always rely on you guys to give us a civil BAM so that we can get the electrical equipment out there. But what happens behind the scenes before you get the BAM? Is that something you can
And what's a
give us?
BAM?
And
Yeah.
a buildable area map, right?
yeah, nice job. Right. So I think Byron talked about this a little bit too,
Yeah.
but hydrology is certainly something that gets kicked off right away. And then EVS survey is often out there doing topo, right? They're either, they're flying their drone or their plane and getting the topography mapped out so that we can have a reliable surface. I was just talking to someone in survey and telling them that, early stages before you get topo, sometimes you have to rely on public topo. And we just had a terrible public topo where
And what's topo?
topography, it's just
Topography?
short for topography. Yeah.
Okay.
So just getting your elevations of the ground elevations. But yeah, the one that we were working with, the trees got captured. And so the elevations would go up for a tree all over the site, which, is not very accurate. It's kind of garbage topo to work with. So, having good topo is a great starting point. Sometimes that happens at the beginning of the process. Sometimes it happens around 30%. It depends on the project. Also having a really reliable survey map of your parcel lines and any existing structures out there. So the mapping done by survey called an ALTA. So we get that ALTA to work with. Sometimes that includes like FEMA information, using any existing wetland information. So we take all of those existing features and the topo, and then we also do some due diligence with the AHJs, the authorities having jurisdiction, in order to see what kind of requirements are involved with setbacks so that we know where the equipment can go. So then that comes together in what we call our BAM, or the buildable area map, so that we can pass that along to electrical and they can.
I didn't know there was
trackers
so
in.
much behind this. I thought you guys were just drawing lines.
Just drawing them wherever.
So how does this all relate to the big question for us electricals? What is grading, right? So all this is going to come into grading the site, correct?
Right. So once we hand off that buildable area map, and electrical decides where the most efficient way is to lay out the trackers, then we get that layout back as civil engineers, and then we start implementing grading. And that lots of different types of grading. We do grading so we do some we call mass grading, which is it could be for high water levels. Maybe there's a certain depth or threshold that we want to meet, provided by, our tracker design, and that has to do with the structural design. So we do some grading for that. We also do grading for the trackers. Tracker grading is helpful in that, the trackers, depending on the type of tracker it is, need to have a relatively flat area. They can't have a lot of undulation, or they can have some, but there are limits, right? And those limits are determined by our tolerance that we have, our tracker grading tolerance. And then again, that kind of coordinates with structural as far as how much allowance civil team has for grading, and the zones and the pile sizes. So there's grading for that. There's grading for the inverters. Often there are requirements for the inverters to be a certain threshold above either a 100-year storm event or.
Is that why they're all like on a mound so that they're
Yes.
just okay?
And you all are designing that mound, right? That's what I was going to ask. Okay.
Yeah, so it depends on the area that you're in, there's a freeboard amount or amount of space that you need above. It's typically the 100-year, 24-hour storm event. So that's mapped out by our
Hydrology.
Yep. Okay. So Byron and the Water Resources Department gets a surface for us, and then we have that level of where we're predicting the water would be, that elevation for a 100-year storm event, and then civil grading based on the jurisdiction that you're in. It could be like a county requirement. It could be a structural requirement, an owner requirement. So kind of pick the highest or most conservative of those three. And then, like I said, maybe it's 12 inches above high water level. Maybe it's 24 inches above the adjacent grade. So whatever that may be, get the grading in for that. And then there's grading for balancing, which you probably, I don't know if you really get into any of that. But so basically when you're moving dirt around, doing earthwork or grading for these sites, you want to make sure that it all balances out in the end so that you don't have to import dirt from other sites, or you don't have a bunch of dirt left over and don't know where to put it. So these sites are big enough that I don't think I've ever worked on a project where we've had to import dirt or haul it off site. But in order to get that balance, you have to, run calculations, and sometimes you have to put a little extra dirt in areas that didn't necessarily need grading for any other technical purpose, but a place to, level it out, make sure that you're balancing the site. So
for a site, these sites are so huge. How does that calculation work? I mean, I just think of the challenges of multiple parcels and spanning a few miles. They could, how does that calculation, what do you use to make that calculation or to do that calculation?
Yeah. So what we do is we work with the contractor and establish balanced regions. So, your site might have 5 to 10 regions that you want to make sure that, basically they don't want their trucks having to drive miles, which could be the case with these sites and how large they are. So they don't want them to have to haul dirt miles to another
just
spot.
To go back and forth.
Right. And that is, that's money to them. So, so making sure that we're balancing within the areas that we've worked out with the client. And then another thing that comes into play for civil is what's called shrink and swell. So when you have dirt in the ground, it's a certain size. You take it out of the ground and it actually is a larger size. And then you put it back in another spot and compact it. And you have to be able to calculate the differences between that in order to, accurately predict what's going to happen with the grading and the balance. So that is something, especially I think the largest shrink factors I've seen come into play with the desert sites. Some of the sites in Arizona.
Is that because it's sandy?
Yeah, and then also because of dust control. Some of the areas you have some dust control where you actually have to water as construction's taking place so that you don't get a lot of dust
just flying around.
Yeah. And so when you're doing that, when you're adding the water, the shrink, even though it's maybe a geotechnical factor or calculation, there are some other factors, whether you're driving over it and using a watering truck. And so, yeah, that's something that civil helps to predict and try to keep the site balanced.
Are you using all 3D AutoCAD when you're doing grading and stuff? Because we don't use a lot of 3D.
Yeah, so we do a lot with 3D because we're working with surfaces, and AutoCAD Civil 3D enables us to use those 3D surfaces and make comparisons between surfaces. We paste them on top of one another. There's just a lot more functionality in the 3D for surfaces than 2D CAD.
Okay. So kind of going off that I just was wondering, I think, do civil folks tend to go on site visits pretty early in the project to get a look at the site conditions? So versus for us, we'll go to the site after it's already been starting to be constructed. But is that a thing where civil goes earlier?
Yeah, that's actually a good point. So early on in the process, we have what's called pre-design site visit. Sometimes what we do is we wait till a 30% plan has been submitted. And that way we kind of have an idea of where everyone wants to put, this is where we think everything's going to go.
Yeah.
We've got a cool tool that we use in Avenza Maps. I don't know if you guys have used that one, where we can geolocate our plans. And so you can, with these sites that are really big, you can walk around the site and see with a blue dot on your plan where you are with respect to okay, here's this power block, or here's a basin that we wanted to put in, and let's look here on the site and see if that's going to work or how that's going to work.
So moving forward with other civil items that you work on, so permitting is a big one that civil is responsible for, and there's separate permitting for the fencing as well, right? So are you responsible for fence layout, fence design for projects?
Yeah, I would say permitting is a big part of the civil design, just making sure that we work with the AHJs, those authorities having jurisdiction, and making sure that we know what, not only what's in their design manuals, but what is not in their design manuals. I think that's just as important to know what they're going to be looking at for review. So some of that does involve fencing.
So each county has design modules that's just online resources that you can go and tap into?
Not necessarily. So some of the bigger counties do have manuals.
Okay.
And then, so a few that I mentioned, like Maricopa County, Kern County. So Maricopa County is in Arizona, Kern County is in California. Those both have quite a few regulations. I would say they're heavily regulated counties. They've got really long review times. So those are counties where, having coordination with the contacts at the county, and also, frankly, it's just, having worked there before and gone through that process, that's probably the biggest help. There are things that we learn along the line. There are other jurisdictions where, counties or cities or parishes, and Louisiana, it's a parish.
Sure.
Where they don't have any information online. They don't necessarily have anyone in planning and development or engineering that's going to review plans. And so those are a little harder. They may not have requirements, but we're still needing to do our due diligence, and then you rely on state requirements as far as how you're designing and good engineering practices. But it is harder to find stuff like that out. I know just recently reaching out to the parish in Louisiana, they had, trying to figure out, any setback requirements and making sure we're doing our due diligence. They had pointed us in the direction of the police jury. So I was like, all right, I guess I'll call the police jury and see what they have to say about this. So trying to connect with the right people, super important. Make sure that we've got those requirements taken care of.
Let's talk a little bit more about, I know you wanted to talk on, you're the training manager also for civil here at EVS, and I see you doing your lunch and learns. Is it every once a month? Is it every other week?
Yeah, so I think before I was a project manager, I was actually helping out with training, and I'm currently the civil training manager, and that's been a fun role. I think, it's definitely evolved. I feel like, 5.5 years ago, our civil department was small enough that we were meeting around a ping pong table for our department meetings. And, Noah Waterhouse was the only project manager. We'd all line up at his door for questions. And, it's definitely changed since then. We've got a larger department, and with, each year we're hiring more individuals. And a lot of these individuals don't have a background in solar. And I'm sure in electrical, you might be doing some of the same recruiting and hiring great people, but need to, train good designers, but need to be trained in solar and some of our standard operating procedures or design procedures that we do. So having a program where things are organized and we've got lots of resources, that's been a focus in the last few years. And so it's been great.
So from every day when I work on projects, a lot of the days are standard, it's everything is moving smoothly. There are days where, I hit roadblocks and I'm unable to figure out a solution, or something in the design has changed and we're not able to accommodate it. I'm sure civil has a lot of those instances as well. Is there an experience like that you can share with us where you hit a roadblock and, you're against time and you're trying to figure it out, and how did you kind of go about that? Maybe share an example with us.
Yeah, recently we were working on a project in Texas, and most of the counties or jurisdictions in Texas have very few regulations, but this county was different and had a standards manual with their standards design manual for engineering and stormwater design. And so working with that county, they had not had any solar projects in their county before. And sometimes the regulations that are there for civil engineering and stormwater management are geared toward commercial or residential projects. And oftentimes that AHJ or the county won't really know what to do with these stormwater or these solar projects as far as should we enforce this? Should we not? How do we regulate the how do we count panel imperviousness? So that's something that was a little hard because, I felt like the county was having a hard time figuring out how they were going to regulate and review this project. And we, from a design standpoint, we were like, okay, this project might actually not be feasible if we are required to do the same things that you would do for a residential project. It was a big deal where, the client and owner were, we were involved in the discussion there on what to do next. And so we met with the county. We actually went down there, met in person, and tried to work out, this is our design approach. This is what we've done in other nearby counties. This is we propose. And they were able to help us as far as getting that understanding of where we were coming from. They were wanting the project to move forward. I think they were just in a tough spot where they didn't know how to review or regulate it. And so by us going down there and talking to them, we were able to apply for a variance and it moved the project along. So that, helped everyone out, kind of relieve some stress on our part as far as the design, and we were able to move forward.
Are those meetings usually like a Senate hearing? Because that's what I've heard, where you're like, they're just sitting high up on the table and they're posing questions and EVS is just answering. Is that how it is? Or?
No, this one was very informal. It was just, us meeting with their planning and development supervisor in a small room and just.
So it's all relaxed and it's just more of an education process, I guess.
Yeah. I have had a judge, though, be, when we're asking for, okay, who do we talk to about reviewing this project? And one county said, oh, it's going to be Judge so-and-so. I thought, okay, here we go. So
it wasn't in the
we didn't have to go
job profile.
Yeah, we didn't have to go to the courtroom, but he was in charge of the boring across the road. So,
Yeah. I think it's interesting that you bring that up because I feel like a lot of standards for electrical, solar is still fairly new industry. And a lot of the standards that people have been using for the last 20, 25 years come from other industries, and they try to apply it to solar, which it just doesn't make sense. Yeah. So it's interesting to even hear that like AHJs are still struggling with, we haven't done a solar project here before. So we don't, we're requiring you to have storm drainage for what we would do for commercial or residential, which just doesn't apply. So it's interesting that like it's the whole scope of a project, of a solar project, that we're just on the leading edge, having to educate clients, HGAs, and owners on the standards that you would typically use for a commercial industrial application will not apply here, or even a substation application wouldn't apply for a solar site. So it's interesting to hear it goes all the way from the AHJ and permitting, to electrical.
Yeah, sure.
So I got a question for you. There's certain things that I do that I really enjoy that maybe like give me a lot of, pride, or I'm really proud of something I've done. And maybe other people don't really care about it, but I really do. And it's kind of one of those things that gets me excited for the job. What is it that you do that you get really excited for, or you're really proud of that you do?
There are probably a few things. I feel like one thing that's super exciting, and maybe this is the same for you guys, but when you like push send on those submittals and you watch that email go out the door, and you can feel good about like, we had great QC, we had good design meetings along the way. We were able to send out a really good product. I feel like that is, that's special, just to be able to be like, okay, for this 1 second, like we're done. First of all, and like proud of the work that we sent out. And I think another one would be doing site visits. Once in a while we're called out there like, hey, we've got this issue and this is what we're seeing on site. And being able to go out there and kind of talk through those, those problems and come up with some potential solutions to help out the site team so that they can move forward with their work and, schedule for installation or whatever it may be can move forward. I think that also, it's a great feeling to be able to be helpful that way.
Is it different when you're an engineer versus a manager? Because sometimes as an engineer, I'm always solution focused, but I think managers, maybe they're like, okay, if my team's happy, that's a win for me. Is that something?
No, I think it's the same. Like I'm a mom, and when my kids are happy, like it makes me happy. I think that can be applied as far as, having a happy team helps to have a happy project manager. And luckily my team's, they're pretty awesome. So I feel like, shout out to the Castaways team, because they make my job a lot easier as far as, we have very little drama going on. So it's a good group to work with.
I know we spoke about training, and I'm curious to know what you're looking for in interns or new hires coming in. I'm sure like what you're looking for now was probably different from what you were looking for in a civil engineer maybe 10 years back. What is it that you're looking for today?
Yeah, I think for a civil engineer, like, new grads, I think, what you're getting in a classroom is awesome, and that's a good base. But I also think for solar especially, being able to have that attitude of flexibility, think of maybe not knowing what's coming up next week, and being able to, we talk about that solar coaster all the time. Things change rapidly as far as, okay, we're doing this project, we're on hold, we're moving up this middle date. I think there's a lot of change going on. And so someone who has an good attitude and is able to be flexible goes a long way with the fast pace that we're working in. Also, just being willing to learn new things. I think, like you said, there's a lot of new technology out there and new opportunities to learn different methods to do things, and also just being curious, having that, creative mindset where you're curious about, could I do this differently? Is there a better way to do this? Instead of, getting a workflow and just, this is how I'm going to do this every time. I think just thinking beyond that on, how to make a better design or how to make a process faster. I think, one of the cool things about EVS is just the diversity that we have here. And I feel like that diversity leads to it, not everybody has the same background or the same skill set. We've got somebody in water resources that's super at programming, right? Yeah. And you wouldn't really think, okay, that's not on the checklist of hiring someone in water resources. Like, they must be able to, be fluent in Python, right? But it's a skill that's actually, super handy at trying to help our department in making some of these CAD processes that are repetitive go faster. And that way we can spend more time on design. So that's an example of somebody who maybe wasn't the cookie cutter, like this is the checklist of what you need, but has had a big impact on our department.
Is that changing how you guys have your list of requirements now that you're seeing people with different backgrounds have a lot more influence? Are you guys actively doing something like having a new checklist saying, okay, maybe Python is something that a new person coming in should probably have? Is that a way you guys are thinking? Or
I think it's more of just keeping an open mind. Right? I feel like, Noah 5.5 years ago he had an open mind about like this mom that's been at home for 10 years. And so having an open mind to somebody who might not be that cookie cutter, like designer right out of school, like maybe they've got practical skills in construction, and then they'll be able to hop in and really like know exactly what our designs are going to do out in the field because they've been doing it for a number of years as they've worked in construction. So I think just having an open mind and looking for those with diverse backgrounds.
I like that because I do agree here at EVS, the different diversity that we have. We try to find what is it that you're good at that might be a little bit different, and then allow you to be creative with that. I have some people on my team that have a different background. I have a person who's got a background in high tech, and so he's really good at programming. And obviously we're looking at automation options. And then it's just one of those things. He can do all sorts of engineering things, but not everybody can do the programming that he can. And he can teach himself new program languages like in a weekend, and then figure out how to use that to automate certain things. And so EVS allowing him to be creative and look at different solutions, it's definitely helping progress what we're doing here at EVS. I definitely agree with what you're saying. Not every background needs to be cookie cutter, and EVS is willing to look beyond a list of this is what you need, and this is a different thing you can bring to the conversation.
Yeah, we should have them get together with our water resources.
We have.
Okay.
Yeah. Any final thoughts? Anything you want to throw out there to us electricals that we don't know about civil?
Yeah, no, one of the great things about EVS, I think, is just being able to have a great relationship with people who are working in different departments. I think it's nice. We just gathered this week for our Pi Day event, just getting to see people on a regular basis and get to know them. And it makes for better communication, I think, overall, and just being able to coordinate and jump on a call or talk to someone candidly about something that's coming up on a project. I feel like it's a little less contentious, I guess, when you can have those good relationships.
One thing EVS does very, very well is builds relationships internally and externally. And you're right, it makes communication much better. Once you know somebody in personal level, you're less likely to be more irritated, I suppose, with them or let that irritation show. So
yeah, and I also think the education, I think between cross-department education that we try to, incorporate here, I think goes a long way when we can learn about, why you don't want to move the trackers when we've got the perfect basin location,
Right.
So when we know the whys behind it, we can kind of work with you, or when like, hey, this basin has to go here because of X, Y, Z, and you guys understand that, it just helps us to make those changes and have those connections in order to work to move projects forward.
Yeah, it's a good point, because it's like lessons learned for future projects, right? It's like maybe I had this interaction with you and you're like, we need the basin here. Or maybe probably saying we can't move our stuff over here, and then we know why. And then maybe the next project we'll work on together, we talk about it really early, and can take that lesson learned. And
I mean, I learned about basins the hard way. So because I just put trackers wherever empty space was, and next thing you know, Civil was shouting at me, where am I going to put my basin? So then I had to really deep dive and figure out what a basin is, what's it actually doing. Okay, how much space do you need typically? So
yeah, got to share, right?
Yeah.